All right, so finally, we're going to talk about chaining multiple decorators. Now, chaining multiple decorators is quite simple, okay? We don't really need to do anything really specific. Simply adding multiple decorators, we add them one after another, and they will be invoked one after another, okay? The order of the execution is preserved, so the first decorator that we declare is going to be the first one invoked, second is going to be the second one, and so on and so forth. So here's an example. Let's say we have our log function with our operation. So we've used this log function in the past and we know what it does, right? So it checks for the argument. If it's smaller than 1, the argument is invalid. Otherwise, it calls our function. But next up, I want to have another decorator, something like beautify. Okay, I simply want to print some stars before the actual execution of the function, right? Just to make it look a bit nicer in code. And then I have my square function that returns the sum of the squares of the numbers in a certain range. All right, so let's go ahead and put this in our code and try it out. So I have here the functionality that we already had, right? So I have my first decorator, I have my square function, I have my log as the @decorator here, and I call it with square 10. So let's go ahead and run this. And we get the operation has been registered, the operation has completed successfully, and we get the result. Now, let's create another decorator here that I'm going to call def beautify. And I'm going to have the function here as well. So I'm going to define inner. Okay, not to call it wrapper again, I'm just going to say inner, but this one needs to take an argument as well because my function takes an argument. So here I want to print out some nice decoration. So for instance, a bunch of stars on one line. So I'm going to say list comprehension. I'm going to print a star with the end equals empty string. Okay, for I in range of, let's say, 40 stars. Then I'm going to print an empty string. I'm going to print here the, first of all, let's get the result equals func of arg1. I want to print the result, okay, because I want the result to be in between my stars. Then I'm going to print the stars again. I'm going to do another empty print, and then I'm going to simply return that result. All right, and finally, I will return my inner. So return inner with no parameters. All right, so I have my beautify. Now let's go ahead and put our @beautify here. All right, so we will get the beautify after my log. So let's see what happens if we run this. We will get the operation has been registered. We will get the stars. Okay, so I have some stars here, 285. That's because I am simply returning the sum here, but I could return a list comprehension directly. So let's see what happens there. And then we get the output like this. I don't want to print it at the end. I just want to call the function so that we get the result in between the stars only, right? So the reason I get it here is because I have my function call here in between my printouts for the stars. So there we go. We have the first decorator, we have the second decorator, we have the result of the function, and then the other printouts from the decorators as well. So finally, we're going to talk about decorator return values. And the main idea here is simple as well. So if the decorated function returns a value, then the wrapper, the inner function of our decorator, must also return that value. Okay, very, very important. It's the same idea with the parameters for the function. If the function has parameters, the wrapper must have the same parameters. If the function returns a value, the wrapper must return a value as well. So how do we do this? Well, it's quite simple. So let's say our square function returns the sum of the squares of those numbers, right? From 1 until size. So we want to print the square of 5. And here in the wrapper, we need to return something, right? So the function returns something, so the wrapper must return something. So we can check if argument 1 smaller than 1, then we return nothing, okay? Otherwise, we simply get the result of the function in a variable like this, and then we simply return that result. So let's put this in our code. Now we're going to reuse the code from the previous lecture. And here in the square, instead of this functionality, I'm going to replace it with a return of a sum of, let's say, we have a list comprehension here. I'm going to have I times I for I in range of 1 and size. Okay, so I just want to get the sum of the squares of the numbers from 1 to size. Okay, so I get that. Now I'm going to print the return value from this function. I'm going to put 10 instead of 5. Now let's modify the wrapper to actually return a value. So in this case, where we don't actually run the function, we simply return. So that will return nothing basically. But in this case, we must return the value of this function, and we must run the function before we print out the message that the function has completed. So here, I'm going to simply say result equals this function. So I'm going to store the result of that function in a variable, and then I'm going to simply return that result at the end. Okay, so let's go ahead and run this and see what we get. Now, of course, we would get operation has been registered and has completed successfully. The reason for that is we are printing the result at the end. Okay, so we are printing the message and then we are returning the result, and then finally we are printing that result. So the result will come in afterwards. Okay, there really is no way to do otherwise because the function needs to return that result and not print it. Okay, so we will decide later on what we do with it. But the important thing is the execution is done between those printed values, okay? Those printed messages. So the execution itself, if it fails, the final print will not be printed. But if it succeeds, then the result it will be returned. Now, what happens if I try to print the square of -3? Let's see. Well, we get the argument is invalid, operation failed, and of course, none was returned from this return value. Okay, we are returning nothing, a none value, so we are printing that here at the console. So that is the main idea. Parameters that go into the function must go into the wrapper. Anything that is returned by the function must be returned by the wrapper as well, if it makes sense. Otherwise, we can return pretty much anything, right? So the wrapper really has control of that function's execution and can return anything really, but it's usually good practice to return the right output of the original function. All right, so in this video, we're going to talk about decorator parameters. Now, the decorators can take some parameters that the functions have as well, right? So if a decorated function has parameters, then the inner function of our decorator needs to take those parameters as well, right? So all the parameters of the function will be passed to our inner function, to our wrapper. So here's an example. We have the square function for numbers in range 1 to 6, and then we are printing the square of each individual number. And we have the wrapper function that has a print statement before and after the actual function. So before we put any parameters, let's put this structure in our code. So I'm going to define a log, and here I'm going to pass my function. I'm going to define a wrapper, and here I'm going to print something like the operation has been registered. Okay, I'm going to say func of, so call the function and then print the operation has completed successfully. Okay, and then I'm going to return my wrapper without the actual call, and then I'm going to mark at log my def square. Okay, I'm gonna have for num in range of 1 to 6, and I'm gonna print num times num. Okay, and then I'm gonna call my square function. Okay, so if we run that as we are expecting, we will be calling the function with the log messages before and after. So this we already know. Now, what happens if the square function has a parameter? Let's say we have a size and we want to do range from 1 to size, and we call the square with the size. So that means our wrapper must take one parameter here, okay? Because the parameter that is passed to the wrapper is the one that will go into our function. Okay, so let's modify our code. I'm gonna add a parameter size here. I'm gonna use that to do the range of until size. I'm gonna pass, for instance, 10 in my square call. And then that means the wrapper must take an argument that will pass to the function itself, right? So let's go ahead and run it like that. And then we get the function with the parameter like that. So we would get the squares of all the numbers from 1 until 9 without including the 10. Okay, so the operation has been registered, has completed successfully. But of course, the main idea here with parameters is that we can actually use that parameter to perform some operation in our wrapper. Okay, so for instance, we don't need to print the operation has completed successfully unless the operation has indeed finished successfully, right? So here we have an example. We are checking if the argument is smaller than 1, then nothing will get printed here, and I can simply say the argument is invalid, operation failed, else I'm going to actually call the function and perform the operation. So I can even do some, let's say, preventative measures here so that I don't call my function with variables or with values that are not suited. Okay, so here if I call with -3, then this will fail, or rather it will print argument is invalid, and it won't even call my function. So let's try that out. I'm going to modify my call here to -3. And here in my wrapper, I'm going to say if argument 1 smaller than 1, then I'm going to print some error message. So something like the argument is invalid, operation failed. Now this is still valid because the operation has been registered, has been called, but the operation failed because of the parameter. Else, I'm going to simply call my function and write out the message, the operation has completed successfully. So if I call that with -3 as a parameter, then I'm going to run this and we get the argument is invalid. If I call it with 5, then that will work, right? So we have the check for the argument in the wrapper. So we can pretty much put any functionality we want in the wrapper. We could or we may not call the function depending on how the logic of the wrapper function works. All right, so what are decorators? So like we said, decorators are basically functions that can modify the functionality of another function, right? So we can apply a function to a function. So basically they change the behavior of another function, or they may add behavior to a function. Now, there are some foundations on which our decorators rely upon. So the foundations are, first, that a function can be stored in a variable. Okay, we already know that. We know that a function can be passed as an argument to another function. So that means we have higher order functions, and we learned about this and we practiced this when we were talking about lambda functions and higher order functions. And then we know that a function can be returned as a result by another function. Okay, so basically a function can add as any other variable. Okay, we can pass it around, we can move it, we can return it, we can do pretty much anything we want with it. So that's the main idea behind decorators, because decorators will take as arguments the function that they decorate. Okay, so let's take an example. And I'm going to go through an example of how we might achieve this kind of functionality. So adding behavior to a function without decorators. And then we will see how that would work with decorators. So we will see that decorators are simply a shortcut for some code. Okay, so let's take a simple example. Let's say we have a function hi that just prints a message to the console. Now, what we want to do is when we invoke this function, what I would like to happen is this function will be ran twice and then finish, right? So for every invocation, I would like this function to be run twice. So we would have a decorator function. Okay, I just put it the name decorator so that it's very obvious what it does, but you can name it anything you like. And inside this decorator function, I have another function that is called the wrapper that executes my function that I pass to the decorator twice. So you can see here, I'm calling it twice, and then I am simply returning this inner wrapper class. Now, how do we call this function? Well, we can say function call equals decorator say hi. So what I'm doing here, I'm having the variable function call the result of this decorator say hi function, which will be the wrapper. So when I execute the wrapper here, it's going to call my function twice. So that is basically how the decorator function adds or modifies the behavior of another function. In our case, the say hi or hello, how are you prints out a message, right? So let's take a moment, put this in our code, verify that it works, and then we're going to move on to see how we can change this code to act as a decorator. All right, so we have here a def decorator function that takes a func as my parameter. Okay, this is going to be a function that we can call. Then I'm going to define a wrapper function inside, and this wrapper function provides the functionality for my decorator. So I'm going to say func twice. There we go. And then finally, my decorator function will return the wrapper. All right, now I have my def say hi function. Simply print out a message. Hello, how are you? All right, so I have that. Now I'm going to create a variable function call equals decorator say hi without the brackets. Now this will return the wrapper. So in my function call variable, I will have the wrapper function. So if I go ahead and call function call, invoke it as a function, that will run my wrapper and will execute my function twice. Okay, so let's go ahead and run this, and we get hello, how are you twice. All right, so that is the main idea behind a decorator. Now, the decorator itself is a shortcut for this kind of structure. So let's have a look. We can simply mark this function with the @decorator, okay? @decorator, the name comes from the decorator function that I have created. And in this case, I only have to invoke the say hi function, and the execution inside here will happen, right? So let me just comment out this code. I'm going to put here @decorator. So the name has to be the same as the other one. Okay, and I can simply say hi as a function. I run this, and then we are getting the expected outcome, right? So this function has been passed to this function, and then this one can execute in whatever form or shape it wants. So that is the main idea behind a decorator. A decorator is this function. Basically, it modifies in some way the execution of my say hi function. All right, so let's take another example, okay, to kind of clarify a bit and practice a bit our decorators. So let's say we have a function that prints the squares of numbers 1 to 5. And what we want to do with our decorator is we want to add some logging functionality in for this function, right? So how would we do that? Let's say we have this square function, okay? Let's put that in code. Okay, so I'm gonna have def square. So I'm gonna have for num in range of, let's say 6, I'm going to print num times num. All right, so I'm just gonna print out the squares of the numbers 0 to 5. All right, now what I would like to have is a decorator function that prints out some logs before and after the function. So what I would do, I would create a function log, okay, that takes a function as a parameter. I would define a wrapper inside my log function. Inside this wrapper, I have the functionality that I want. So I modify the original functionality in the way that I want. And then I return this wrapper. And then finally, I mark my square function with the @log decorator. Okay, so I'm decorating the square function with this log decorator. All right, easy enough. Let's go ahead and define our decorator called log that takes a function as a parameter. Okay, now I'm going to define my wrapper. You can name this whatever you like, by the way, but I just call it wrapper because it's wrapped inside our function. You could call this wrapped if you want. That's just fine. It works just as well. So I'm going to say print the operation has been registered. Then I'm going to call my function here, and then I'm going to print the operation has completed successfully. Okay, so I'm kind of wrapping the execution of my function between these print statements, and then I'm simply returning the wrapper here without the call, right? I'm just returning the wrapper itself, not the call to the wrapper. All right, so all that's left to do now is mark this square function as @log. Okay, so the decorator has been created for us because the function has been defined. We can have the log, and then we will simply call square. We call the function, and let's see what happens. We would get the operation has been registered. We get the result of our square function, and then the operation has completed successfully. So we have decorated this square function with our log function. Okay, so I'm hoping that you can see now how the decorators work and how what is the power basically of an operator, because it allows us to provide some common functionality to multiple functions, right? So we can apply this log to the square, but we can apply it to pretty much any function that we want in our code, right? The execution here is the same. So it allows us to take some code out of our functions, put it in a decorator, and apply that decorator to as many functions as we want. So it's quite a powerful mechanism that Python provides for us.